Lesson 8-5, line plots, 1/2, 1/4, and 1/8 inches. The focus of this lesson is for you to consider perimeter length and height, for you to share ways of thinking about the math message, and for you to make a line plot and answer questions about data measured in halves, fourths, and eighths fractions of an inch. But first, let's start with our mental math and fluency. As you can see on the screen, we are subtracting fractions. 5/6 minus 1/6. Denominator is the same, so subtraction with the numerators should be easy. 4/6. Again, 9/10 minus 5/10. The denominators on the bottom are the same, so we subtract the numerators, and 9 minus 5 is 4/10. Remember, never ever do we add or subtract the denominators that are on the bottom. Read this silently to yourself as I read it out loud. It says, Sydney wants to mail a thank you card that is 5.5 inches high and 8.5 inches long. Would knowing the perimeter of an envelope help Sydney determine whether the card will fit in? Be prepared to support your answer with an example. Well, let's think about that. If I want the card to fit, the length and the height of the card and envelope are super important. The envelope needs to be just a little bit bigger than the card so that the card will fit inside. Knowing the perimeter of the envelope doesn't tell me whether the length and height are both a little bigger than the card. So again, knowing the perimeter of an envelope tells me the distance around it, but not the specific length and height. The perimeter of the envelope that would fit Sydney's card would be a little more than 28 inches. Because 5.5 inches plus 5.5 inches plus 8.5 inches plus 8.5 inches. So another possible envelope with a perimeter of 28 inches would be 2 inches high and 12 inches long. So 2 plus 2 plus 12 plus 12. The card wouldn't fit in that envelope at all. So knowing the perimeter of this envelope can only help Sydney determine whether or not the card will fit if the perimeter is less than the perimeter of the card. If the envelope's perimeter is smaller, the card won't fit. So in this lesson, you will make line plots displaying the heights of envelopes measured to the nearest eighth inch. Next, open up your math journal to Math Journal pages 286 and 287. Read this to yourself as I read it out loud. It says, The Right Stuff, a stationery store, sells a variety of different size envelopes for businesses and personal correspondence. The heights and lengths of the envelopes are given in the tables below. All measurements are in inches. So you should be looking this on Math Journal page 286, and you should be looking at pretty much the same table that you're seeing here. Now, on page 286, it says, plot the heights of all the business and personal envelopes on the line plot below. So first of all, you're going to need a title for this line plot. Well, remember, what is it that we're plotting? We're plotting envelope types. So that would be our title. So envelope heights. Sorry this takes me so long. I wish there was a quicker way to do it. Then it asks you to give it another, what are your numbers here? Well, those numbers represent the height in inches. Remember, that's what it said earlier. And we want to state that here because we don't want somebody to think that we were doing it in millimeters or centimeters. We want to make sure that they understand that this height is in inches. And there may be other times when we're making plots where we might be doing it actually in feet or yards. So make sure that we have the correct units written down. Now you're going to make X's representing the information up above. So to get you started, I'm going to show you how I would do this. I would look at the number 3.5 because that is the first number that is going to have an X above it on the line. So as I go up here and I look, I have 1 3.5. I look down the column for business, down the column. That's it. So above 3.5, I'm just going to make one X to represent that I marked it. And then I'm going to make sure that I cross that up above off too. I don't want to write it down twice. So you need to do that for each one of these. So if this is 3.5, what would this next one be? Something between 3.5 and 4. Well, let's count our lines. 1, 2, 3, 4, 5, 6, 7, 8. So if this is 3.5, this actually would be 3 4/8. Once I make sure I have that written down, to plot all these rest of these numbers will be easy. Pause the recording now and mark all of these heights down below on your line graph. Okay, so how does someone decide whether to record a measurement as a half, a fourth, or an eighth? Well, you have to see which fraction of an inch the measurement is closest to. For example, if the height is 4 5/8 inches, you have to record the fraction as eighths because you can't make an equivalent fraction using halves or fourths. If the measurement is 4 6/8 inches, you could record the measurement as 4 3/4 inches or 4 6/8 inches because 3/4 and 6/8 are equivalent fractions. So look at the next one. It says, which allows you to express the most precise measurements? Means accurate. Measuring to the nearest eighth inch, fourth inch, or half inch. Measuring to the smallest unit will give you the most precise measurement. So in this case, it would be the eighth inch. So which is a more accurate measurement? 2.5 inches or 2 4/8 inches? Hopefully you notice they are equally accurate since 1/2 and 4/8 are equivalent fractions. Now I'd like you to answer the questions on Math Journal page 287. It says use the line plot on page 286 to answer the questions. Show your work in the space provided. What is the largest envelope height sold? How many inches? Number 2, what is the smallest envelope height sold? Write that in inches. Number 3, which envelope height is stocked the most by the right stuff? Number 4, what is the difference between the largest and the smallest heights? Number 5, in the United States, the most popular business envelope is 4 1/8 by 9 1/2. It is called the standard number 10 envelope. So how many of the envelopes sold at the right stuff have a height larger than 4 1/8 inches? Letter B, how many of the envelopes sold have a height smaller than 4 1/8 inches? C, how much larger is the height of the number 10 envelope than the smallest one sold? And D, how much smaller is the height of the number 10 envelope than the largest one sold? When you complete Math Journal page 286 and 287, please bring it up to me because it is an assessment check-in. Pause the recording now and finish that for me, please. 286 and 287 were assessment check-ins. Now I want you to go to Math Journal page 285, though, and do the math boxes. How many degrees will Paula need to move the back of her chair to be able to lie flat? So think about your angles, write an equation with an unknown, and then write your answer in the answer spot. Math box 2 says, the Merman family used 3,955 liters of water in a week. The Santana family used 4,263 liters during the same week. On average, how much more water did the Santana use in one day than the Mermans? So right now they're giving you these totals in a week. So you got to figure out a week this amount divided by a week and then compare the two numbers to be able to find out how many ml this is. Lots of directions for this one. Do it one step at a time. Pause the recording and do these math boxes. Math box 3 is telling you to add. Math box 4 to subtract. And 5 is telling you to explain your thinking in problem 1. Please write words to explain this. Pause the recording now. When you are finished, go up to the Math Journal answer key and correct it. If you had anything wrong, stop back at the table and I'll be glad to help you. So the last thing you're going to do for Math Lesson 8.5 is Math Masters, page 319. Pause the recording now and go get that out of the file, please. This is asking you to plot the data set on the line plot below. So Nicholas is building a bookcase. To help with the design, he measured the height of each of his books to the nearest 1/8 inch. His measurements are given below. So you're going to do this very much like you did the last one. You are going to look at the height in inches. Notice we're looking at book heights. These numbers are representing the height in inches. So you're going to need to go up, and the first number is 6.5. So you got to go up and go, well, I have 1, 2, 2. Well, I only have 2. So down below, I'm going to mark 1, 2. So please plot the data on this and then finish the questions that go along with it. And the questions read, number 1, what is the difference in height between the tallest and the shortest books? Number 2, Nicholas wants the space between the shelves to be 7/8 inch taller than his tallest book. So how far apart should he make the shelves? Letter B, if the thickness of the wood he uses for the shelves is 5/8 inch, what will be the total height of each shelf? Hint, the total height is the thickness of one piece of wood plus the distance between shelves. And next, finally, I want you to do the practice. Bring this up to me when you get it completed before you move on to lesson 8.6.